Students, in this paragraph it is saying that a point like object of mass m moves along this track and leaves this point B in order to reach this point C. This vertical track, it is a vertical track, means this track is in vertical plane. Now the first question over here is saying determine the vertical initial velocity of this point like object. In question 2 it is saying what is the minimum possible distance OC. This is the OC. We have to find this minimum distance if this point like object will not going to lose contact in this track. Okay, and in third question it is saying find the normal force exerted by the track at point A, means at point this we have to find the normal force acting on it. So let's see the solution. See, this particle will going to move from here till here. At B its velocity will be tangential, so I can draw VB like this along the tangent. This will be velocity at B, and there will be no component of velocity in vertical direction. After leaving B, it will going to follow projectile motion from B to C, because it will going to move under the influence of gravity only. So what I can write VB as displacement in a horizontal direction divided by time. So I have written VB equals to d by t. This is my equation number 1. Now displacement in y direction, or you can say in vertical direction, will be minus r. So minus r, initial velocity in vertical direction is 0, so I can write 0 minus half gt square. From here the value of t will come out to be 2r by g, under root of 2r by g. This is my equation 2. Now putting the value of t in equation 1, I will going to get velocity of b as d divided by under root 2r by g. Okay, this is my velocity at point B. Now what I will going to do, I will going to apply conservation of energy between K and B. Why? Because there is only conservative forces acting between K and B. As there is no friction, there are no non-conservative forces. So I can apply conservation of energy between K and B. On applying conservation of energy between K and B, what I will going to get? Initially I have assumed the reference point as K, so initial gravitational potential energy will be 0. There will be only kinetic energy, it will be half mv0 square. And at B, the gravitational potential energy will be mg h plus r. So initially to half mv0 square, that is only kinetic energy, and at B it will be potential energy mg h plus r plus half m vb square, that is velocity at B ka square. Now I can write v0 square, m and m will going to get cancel out, this 2 will go over here, so it will be 2gh plus r. Putting the value of vb square from here, I will going to get d square divided by 2r by g. So v0 will come out to be under root of gd square upon 2r. This g will going to go up, so gd square upon 2r plus 2gh plus r whole under root. This will be my answer. Now this is given in option C over here, so my correct answer will be C to this question. Now see the second question. The necessary condition over here is it will going to slide along the entire length of this track, means it will not going to lose contact anywhere. So the minimum velocity at B will be there if it will not going to lose, means normal over here, I can write normal here over here will be 0. If normal over here is 0, this is going to satisfy my condition that it will going to follow this whole entire length of the track without leaving. So see what I have written over here as d is equals to vb into t. I have already explained you, so I can see that t is fixed because the displacement in vertical direction is fixed, acceleration is fixed, so my time is also fixed. So d minimum will be equals to v minimum into t. Now see over here what I can write, normal will be 0, so there will be only force acting in vertical direction will be mg. So I can write mg equals to mv square by r. mv square by r will be equals to mg. For v minimum, normal will be 0, so mv square by r will be equals to mg. This is the condition for this particle to not leave this length of the track. So v minimum will going to come out over here. I can calculate v minimum, m and m will going to cancel out, so v minimum will be under root gr. Now putting the value of v minimum over here, I can get d minimum will be under root gr into under root 2r by g. Now this g and g will going to cancel out. It will become r square under root, so r will going to come out, so it will be r under root 2, which is given in option A. So my correct answer will be option A, r under root 2. Now in third question we have to find the normal over here. So see, normal will be acting like this over here and mg will be acting in downward direction. So what I can write over here, I can write that normal at A will be equals to centripetal mass into centripetal acceleration, that will be m into va square by r. Again applying conservation of energy between k and A, I will going to apply conservation of energy. I can write half mv naught square equals to mgh plus half m va square. So you can see it will be half m. Now vk, velocity at k, I have already found it over here. So squaring this, I will going to get this term. This will be equals to potential energy at A, that is mgh plus half mva square. From here I will going to calculate the value of mva square, which will going to come out this. Now I will going to put this value in this equation number 3. So my normal at A will going to come out this, which is given in option B. So my correct answer for the third question will be option B. So I hope you have understood this. Thank you very much.